So today I would like to give you a demonstration of Kanidm. For those who don't know who I am, my name is William Brown. I am a senior software engineer at SUSE Labs. I'm better known online as the user First Year. I'm the creator of the Kanidm project, and I'm also part of 389 Directory Server team, one of the major open source LDAP servers, and I'm also the creator of the WebAuthn and Rust library. I'm based in Queensland, Australia, which means that my time zone is UTC plus 10. So for our international viewers, it can sometimes be hard to get in contact with me in a real-time forum. So the best way to get in contact if you have any questions is to send me an email at wbrown@suse.de. So I've worked on identity management for a long time, and I decided to ask a lot of other people what their feelings about identity management was. And I got a lot of responses. A lot of people said that identity management systems and authentication systems in general are very unfriendly. They're hard to approach. The communities aren't generally very nice places. It's complicated to set up. It's difficult to actually know where to begin or understand the technologies involved. It's very fragile, and that complexity turns into fragility, where these systems can break very easily and sometimes without any human interaction at all. And that's a really big problem, because authentication is meant to be something that is reliable and available so that for the security of our systems. And of course, when things break, what makes this even worse is that it's difficult to understand. It's difficult to diagnose problems. It's difficult to put together the pieces to solve what happened to cause that issue. And all in all, this leads to the word that most people described when they thought of identity management, and that word was painful. And I think this set of adjectives and adverbs really describes my own experience with identity management, where I did find it very difficult and painful, unfriendly, and complex to learn and begin with. I've been doing this for a long time now, and even now there are still things that I find very rough. And I think because of this general attitude that identity management is a painful topic, most people shy away from actually running or interacting with authentication services, and they really try and avoid the topic as much as they possibly can. So with this in mind, and given the experiences that I'd had, I set about creating something new. And this is why I created the Kanidm project. It's an identity management project or server and client suite, which is really simple to deploy, extremely reliable, and it's correct and secure by default. The project can be found on github.com at /kanidm/kanidm, and the README has a lot more information about what Kanidm does and how it works. But rather than just talk about what Kanidm is and how it works in front of a slide deck, I'd like to give you a demonstration of how Kanidm works. So, time for a live demo. So everything I'm about to show you is documented here in the Kanidm book. We have extensive documentation which you can find linked from the project README on GitHub, as I already explained, and it's separated into many different topics, but everything I'm about to show is documented here. So if you want to follow along, you can go and have a look at the book, which explains everything that I'm doing and in probably more detail. So, like any good TV chef, I've prepared a number of virtual machines earlier, which we'll be using for this demonstration. And the first thing that we need to do on our Kanidm server is we need to configure a storage volume in Docker. And the reason for this is that, unlike a lot of other authentication services, Kanidm is the database. We don't back onto something like PostgreSQL or MySQL. We are the database, and we do need to have our own data store. So for Docker, we need to expose that. So we're going to create our volume here now. And now that we've created our volume, we can create our Docker container. Now, the Docker container we're making here has a number of options. We're going to expose port 443 for HTTPS, 636 for LDAP-S. We don't support plain text LDAP or HTTP, especially plain text LDAP or start TLS. They're both insecure. You can only use LDAP-S as it's the only secure option. We need to add this OpenSSL legacy config here. This is for something later in the demonstration, and when that comes up, I will make sure to explain what that's for. This is not required by default, however. Finally, we have this Kanidm data volume, which we are going to map to our container, and I'm using a devil version of the container, but everything I'm showing you will be in the 1.50 release, which is due to come out in the next week or two. And when I say week or two, I mean around mid-February 2025. So we're going to create our container now. And now that we've done that, we need to configure it. So we have a pre-configured server instance here. And mostly the server configuration is quite easy. We document all of the files quite extensively and all the options. So our bind addresses, which we can see here, whether we want to trust at the x-forward4 header, if we're behind a load balancer, where our database path is. We have some file system optimizations for different file systems potentially, some cache tuning options, where our certificates are. As mentioned, we require certificates. Sorry about that, my cat has decided to walk on the keyboard. And here we can see the most important settings, which is the domain and origin settings for the instance. These are both really important for WebAuthn and the URL that we're going to be accessing our instance at. Finally, we support online backups here, and you can configure it with this cron style scheduler. For the purposes of this demonstration, I'm running this every 5 minutes. And so at the end of the demonstration, we should be able to see our backups in place. So that's all you need to configure your server, is to set that up. And that example config is available in our book, as previously mentioned. So we're going to copy that in along with our certificates that I prepared earlier. And now that we've done that, we can start our Kani instance in Docker. And there we go. We can check that it is now running by checking the Docker log command, and we can see that we are now ready to rock, which is what we want to see. And we can come over here and go to our demo instance. So here we can see that the instance is now set up and ready to go, but we can't really do anything here yet. We haven't actually set up any users or configured anything. Now, very keen-eyed viewers will notice that I have not set any passwords or anything at all for default accounts. So some people might be asking, okay, well, is there a default admin password? And the answer is no. We don't want there to be default admin passwords ever in Kani. We want to make sure that your instance is secure out of the box. And so what we do is when you're on the system, you have to recover the first admin account. So in order to do that, we're going to run this exec command inside of the running server container, which asks to recover the initial admin account here. So we are now going to do so. And we now get a randomized high entropy password. At this point, we need to be able to log in as our admin in order to start configuring our instance of Kanidm. So what we're going to do is we need to configure our client config. Here's one I prepared earlier, and the client config, sorry, I'll put this in a better spot on the screen, is really simple. We just have the URI to the server and the CA certificate to pin for accessing that service. And it's very important we have this. Obviously, we don't want someone to impersonate our authentication service. And so we want to be pinning TLS. TLS is a very fundamental and important part of the security of this system. So since our config is set up and the CA certificate is in place, we can actually log in here as our newly created admin account. Don't put that on the command line. I got a bit enthusiastic. And we're going to enter that here, and we've now logged in. Great. And we can show that with the who am I command. And you can see that we've now successfully logged in as the admin user on this console. So now that we've set up our instance and we've logged in as our admin, we can do a little bit of customization just for the purpose of this demo. Obviously, in your own environment, you'll want to have your own tweaks and flares as to how your instance looks. So we can do some stuff to configure the domain. The domain is what we refer to for Kani as the scope that encompasses all the groups and users and the configuration. So within this domain, we can now configure the display name, base DNs, whether you want Easter eggs or not, more to come on that space. And you can even configure custom images as the instance logo. As cute as the crab is, not everybody wants the passport crab on the front page of their website, though I personally keep it at home. So what we're going to do here, just for the purpose of this, we're going to set our domain display name. So we're going to set a display name here, and we're going to set our display name to be Kanidm community demonstration. So we're now going to do that as our admin user. And now that we've done that, if we come back over to our instance and I reload the page, you can see that it immediately has taken effect. No server restarts required. The change is just is live. And if this was a multi-server, like a replicated environment, all the replicas, once they're synchronized, which happens in a very short time frame, all those replicas would also be updated to show this. The same is true of the display images and things like that within the server. There's very little which requires a server restart. So now that we've completed that, we need to actually start being able to log in accounts. Now, something that Kani is very strict on is we want proper separation of privilege. So unlike most other systems, we don't just give the admin account unbounded power. We actually have a separate IDM admin account, which manages peoples and groups. So the admin account manages the instance and things like how it looks, auth integrations or synchronization from other services, things like that. But it can't manage people and their personally identifiable information. Whereas IDM admin manages people and their personally identifiable information, but can't manage like how the instance looks. The idea is that you've got a sysadmin team who manages the instance versus, say, a group of people who manage the people and are in a position where they can actually, are trusted to look at their private information. So we separate that privilege by default. So we now need to go through that recovery process again to start creating users with the IDM admin account. These accounts, both the admin and IDM admin, are intended to be break glass accounts. They're built up from a number of smaller privileges, which you can then combine as needed or delegate as required to other accounts. So you don't actually have to be using these day to day. So at this point, we've recovered our IDM admin account and we can log in now as the IDM admin. And now that we've done that, we can begin to configure our instance. So let's clear the screen actually. Oops. Getting too far ahead of myself here. So we can now create a person, and as for all of our commands, there's a lot of help information available. So it makes it really easy to configure and administer your instance. We try to have very accessible commands and a lot of documentation from our -- help flags. And of course, all of this is, again, documented in our book. So it makes it very easy to get started. In our case, to create a new account, we need an account ID and a display name. So we are going to create the account ID as test user, the classic name, and we are going to create them as the IDM admin. So we've now created our user, and we need to be able to log them in. So we need to give them some kind of credential so that they can authenticate themselves. Now, we don't want to know what their credentials are. We want the person to be able to configure and create their own credentials without our involvement. We don't want to be the ones involved in this process. So we can create a reset token here for the test user account. And you can see that when we create this, we get this QR code that you can scan with a phone. You can send the person a link to follow, or they can actually run this command and do their initial account onboarding from the command line with this token. In our case, we're going to follow this link. So we're going to come back over here to our browser, and we are going to log in. Or sorry, we're going to go access our reset token, and you can see here we're now updating our credentials for our test user, for our Kanidm community demonstration, and we get given a number of options here. So that we get offered passkeys, which is self-contained cryptographic authenticators. So this is things like a YubiKey, which has a pin, and that's the actual hardware in the YubiKey has brute force prevention to prevent people attacking the pin. So it's a very secure way of authenticating. And of course, as an alternative, you can still go back and add a password. We try and do a lot of nice stuff if the person wants to add a password. So if I try and set a weak password here, if I can type, good job live demos. And we'll see that the password is too short. It needs to be longer. So we try and give this really nice actionable feedback. So if I type the word password twice in a row, this is much longer now, so of course we can proceed, right? Well, no. Add another word or two, avoid repeated words, repeats are slightly harder to guess. So we try and give this really good actionable feedback, and I want to shout out the ZX CVBN library, which is what we're using here to get really high quality passwords from users to help guide users to create really strong credentials if they're going to use them at all. If the person in this case did enroll a password, so let's actually enroll a reasonable looking password, then we can't actually proceed because multi-factor authentication is required by default. So, and we give this really actionable advice again, add TOTP or remove your password in favor of passkeys in order to proceed. So in this case, I'm going to delete the password, and we are going to use passkeys for our authentication. So I'm going to add one here now. And Apple here, they really want you to use their Touch ID, but I don't want to. I need to click through these little hoops in order to use my YubiKey. So I'm going to connect that now. Okay, and then now I've added the YubiKey here, and I'm going to add that, and we now have that available here. And all of this hasn't yet taken effect. This is a transactional model, so you update your credentials as a whole or not at all, and so we need to save our changes now. So we've completed that, so we've saved, and now we can proceed to log in as our test user. So we can now use our passkey, and this time Apple does make it easy to access your security key. It's already blinking by default. And we've now logged in with our passkey, and it was as easy as that to proceed. So we can, with the passkeys, one thing that we can do with Kanidm. Sorry, I should explain what I've just done here. So with Kanidm, when you log in, you don't actually have access to privileges by default. It's kind of like sudo. Your account is always in a read-only mode, and then you get read-write privileges for a brief period of time. So I've just had to re-authenticate in order to reprove who I am before I can edit my account. That's so that if someone was to steal an account token, they can't actually do anything with it unless they have your physical credentials or know your credentials in order to use them. So this lets us have longer-lived sessions with really nice security features. One of the things that we can do here with passkeys is we can do attestation, which is cryptographic origin validation of the device. So for example, you may only want YubiKeys to enroll in your environment because YubiKeys are the gold standard for a security key today. And so you can cryptographically attest that only YubiKeys can actually enroll their passkeys here. And this is documented again in our book. Kanidm is the only IDM today to support this, and I think we were the very first in the world. We were the first in the world to support first open source IDM to support passkeys as well. So we've really tried to adopt these very secure options for authentication from very early on. Now, something else that's really nice here is that we can actually enroll extra devices. So in order to get to this enrolled device prompt, you need to have done that re-authentication process. So since my session is currently in the read-write state, I can now enroll another device. So for example, if I wanted to enroll my Android phone, since my Apple machine does not have a passkey synchronization to my phone, and maybe my phone doesn't have the capability to plug my YubiKey in, I can scan this QR code and then it will give me that same credential update UI flow on the phone, which makes it really easy to actually enroll diverse devices onto your account. And I can't think of any other identity management platform that offers this and really embraces this idea that there are like very diverse ecosystems of devices for consumers and tries to give them this ability to maintain their own credentials in a really secure way. This token here that I'm showing you actually only lasts for a few minutes, so that you have to use it while you're scanning it here. If you were to take this secret and try and use it in about 10 minutes time, it just won't work. This is something that you have to really be present for in order to actually use this token. So now that we have configured our account and we've gone through a bit about that initial sign-on and how we can use passkeys, what we can do is we now want to actually enroll some applications onto our account. So you can see that we have this thing called an application list. And this is because Kanidm is also acting as a application portal. So it's a one-stop shop in order to log in and then be redirected to other applications that you may be using. Now, I have already set up a Nextcloud instance earlier, and we are going to configure our Nextcloud instance here to authenticate to our Kanidm instance that I have just configured. So what do we need to do to finish this configuration? So in order to finish this configuration, we are going to create an OAuth 2 provider. So unlike a lot of other identity management systems, Kanidm is all in one. We are the OIDC server, we have the LDAP server, we have everything all in one. We don't need external tools like Keycloak is needed for something like an LDAP server. So what we're going to do is we are going to create our Nextcloud application here. So we're going to create a new OAuth 2 application called Nextcloud. We're going to display name, the display name is Nextcloud, and the URL here is the Nextcloud demonstration. So we're going to create that as the IDM admin. And in order to control who can access this as an authorization system, we also need to create a group that can be used to limit who is allowed to access this application. So we're going to create a Nextcloud access group, and we want to add our test user to that group. So we're going to go ahead and add that user now. So we're going to add a member to our Nextcloud access group for the test user. And if we go and have a look at our look at our test user now. Sorry. This is what happens when I type instead of copy pasting. So if we look at our test user, you can see immediately the reverse membership has already updated via the member of. So Kani has this member of attribute, which does the reverse linking of groups, just like a lot of other LDAP servers. So it makes it very easy to check for this kind of authorization element. So our test user is now part of Nextcloud Access, and we have that group to control that. But now we need a way to demonstrate or to share that with the OAuth 2 application. Now, OAuth 2 doesn't have a concept of groups. It has a concept of scopes. So the way that we do this in Kani is we need what's called a scope map. So what we're going to do is we're going to create a scope map for the Nextcloud application where members who are a member of the Nextcloud Access group are granted the following OAuth 2 scopes. And those OAuth 2 scopes are used to actually grant or authorize the application here. So we can see that the scopes that we need for our client configuration here in OAuth is OpenID, email, and groups. So we're going to go ahead and set those for our scope map. And now that that's created, the authorization side in Kani is all done. And what we need to do is we need a way for Nextcloud now to identify itself to Kanidm. And the way this is done is with a client secret. And this client secret is generated on the Kani server so that we can ensure that it is secure. So we're going to show this basic secret here now. Sorry, let me use the correct account. So we show the secret and we can now provide that to the Nextcloud application. And at this point, we can update the provider. And yep, I have done that correctly. And now that we've done that, we should be able to log in as our test user. So I'm going to log out of the admin account and you can see that we now have this login with Kanidm option here. And if we select this, we get an error. Now this is an error that I intentionally put in here to show you how we can debug this. So you'll notice that we have this operation ID here. And the reason that we have this is every log line in Kanidm has a UUID associated with it. So if we look at the logs for the Kanidm instance, and grep for that UUID, we can immediately see this UUID here has popped up. And because of that, we can now identify exactly what log lines pertain to the error that occurred and what happened. So we can see that there was a request here and the method was a get to the OAuth 2 request from the Nextcloud client. We can see that there's timing information here about how long each subsection took as a percentage of the whole operation here. And we can see what the actual error was here. The invalid OAuth 2 redirection URI must be an exact match to a redirect URL. We were sent this URL, which we never configured. And so what we need to do is we actually need to configure our OAuth 2 configuration on Kanidm to know that this URL exists as a safe place to redirect the user and their token to. We don't want someone redirecting the user to a third party or an unsafe URL or anything like that. We want to make sure that we know where they are actually going and being sent to. So we're going to nominate this as a safe redirection URL. And as soon as we have done this, we can now actually go back to Nextcloud, log in as Kanidm, and immediately we're given the correct workflow here. And we're asked to consent. And the reason for this is that every time a OAuth provider asks for personally identifiable information, we want the user to know that that exchange or that information is being given to somebody else. In this case, I trust that my email is going to be given to myself. And so for me, I'm okay to proceed here. But this is something that is really important in Kani, is that we want people who use this service to feel as in control of their information as the people who set up and run the service as well. So someone could say, no, actually, I don't want my email shared with this third party, and then can back out and bring that up in the environment and say, hey, why do I need to give them this email? So we're going to proceed here, and this time actually, we're actually waiting for Nextcloud. Kani's already finished. This part's just a little bit slow on the Nextcloud side, and as you can see, we've logged straight in, and we can now proceed to our environment here. So something that's also really nice about this is that if we come back to our applications list and reload it, we can now see that Nextcloud has appeared. And if we follow this link, we're also taken to our dashboard. So this is what I mean about Kani acting as an identity management portal. It's a really nice way to just say, hey, I've got this application and I'm going to follow the link. As before, you can update all of these logos here to match the application and give something a little bit more thematic to help the user find where they actually want to go. So we're going to log out of Nextcloud here and get on to the next part of the demo. So all well and good. We've now got a user, they can log in, they can update their credentials, and they can log into Nextcloud, so we can log into other services, and we can continue to add more services and enable these people to log in. But like a lot of us, we actually have and maintain a lot of Linux or Unix systems, and we need a way for our users to be able to log into them. So this is what we're going to set up now. So again, we have set up a Unix system over here, which is the target that we're going to be logging into shortly. And what we're going to do is we now want to set up POSIX attributes on our test user. So by default, we don't assign POSIX attributes on users. And the reason for this is that, well, if they don't need it, then why do we give it out? So we only assign them when they're actually needed. So we're going to set up these attributes. And when we do this, the actual UID and GID that is granted to the test user is randomized. And this way you just don't get conflicts and things like that. You can manually control what these data have in them, but for the most part, the auto generation is a reasonable way to proceed. So we've now set that our test user is a POSIX account. So now we want to let that test user set themselves up so that they can log in to a Unix system. So what we're going to do, sorry, I needed some water. What we're going to do is we are going to log in as our test person. Now, as you would have seen before, I only set up a passkey for this account. So I'm going to log in using my passkey on the command line here. So the very same passkey that I set up with my YubiKey in the browser is available on the command line, and I've just used it right now. So I've now logged in as my test user, and I can actually begin as myself to set up the password. Now, the reason why we have to set the password separately here is that we don't, even if the user did have a password set on their account, by default, because Unix systems may expose that password in something like sudo or SSH, we don't want people to be able to brute force that and then use that to exploit the main Kani account, which does have those privileges to modify the account itself. So we try to separate these credentials so they each have their own domain of usage. So passkeys are used to log in on the command line. The password here is just used for the user in terms of when they need to do something like a sudo request. We do, however, push people to really want to enroll things like SSH keys. So we're going to create a new SSH key here. And we're going to enroll this SSH key on my YubiKey. Again, we really want these nice hardware-backed keys, but obviously you can use many different types of SSH keys here. Let me get my PIN correct. And we're going to generate that key. And now we've generated the key here, we can enroll it to the account. So we're actually going to, as the test user, so we're going to, as the test user, we're going to enroll a SSH key to the test user. We're going to label it YubiKey, and we're going to cat the .pub file that we just created. So we're going to do that. And we've now created our SSH key for our account. And if we do Kanidm person get, you can now see that our SSH public key has been configured. We have a Unix password set up, and we can see our authentication sessions where we actually logged in and what credentials were used for that. So we've now set up our user. So the user is ready to go on the POSIX account. And now we actually need to configure the VM to be able to accept the user to log in. So on the machine, we actually have our own NSS and PAM resolver. We don't need anything else like PAM LDAP or PAM Kerberos. We have a PAM Kanidm, and we did this in order to make sure that it was a very secure daemon, and it can do things like storing credentials with a TPM for like hardware binding those credentials so they can't be exfiltrated from a machine. So on this machine, we need to configure the actual Unixd provider. So this is the configuration for that. And again, like our other configs, they're very, very well commented. And you can see here straight away, we support this HSM type, which can bind cached credentials to the local hardware security module. And by default, we attempt the TPM if possible. And this way, if we're doing offline password caching, which is a feature that our PAM modules support, so that you can like pick up a laptop and go out and about and come back, your account will still work. But we want those credentials protected in a TPM so that loss of that laptop won't allow someone to steal your Unix password or other things. So this is the Unix config. Most of this you can probably leave as defaults, but the important value is here, the PAM allowed login groups. So this is what defines the authorization rules of who is allowed to log into this system. And you need at least one group allowed. You can't just allow everyone to log in. So we're going to make it so that this Unix allowed login group is allowed to log into this system. So since we've set up our machine already, I did most of that already. We just installed it and added that one config file. We are going to start the Kanidm Unix resolver. And the reason why this is taking a second to start up is that it's actually benchmarking the CPU of the system to work out how many rounds of password hashing can we do before it's too much. So we try and stay within a time window. And the idea of this is that the faster your CPU, the higher we can pump up those number of rounds to stay within that time threshold. So as CPUs get faster, we're always increasing the cryptographic security of stored passwords on the system. We also have this separate tasks daemon, which is an isolated and hardened process which manages things like home directories. And this way we don't need any external services like oddjobd or whatever. The two major files that actually connect to this is NS switch over here. And we can see that our password and group is set up to resolve users through Kanidmd. And we do want to set that first. Kanidm can act as the default files resolver as well. So it can cache and resolve things from etc password and etc group. And of course, for our PAM files, I've already configured this over here as well. So again, you can see that we don't actually even need PAM Unix. PAM Kanidm can actually replace PAM Unix at this point and authenticate users. So now that we've done that, we've got our user set up, we have PAM and SS configured, we've got the resolver running, we've got the home directory task creation daemon running. All we need to do is allow the test user now to log into this system. So let's actually create that Unix allowed group and allow the test user to be a part of it. So we're going to create that group. We're going to make it a POSIX group because it has to be a POSIX group so that it resolves properly for the service and it shows up correctly in the group lists. And we're now going to add our test user to be a member of this group as well here. So we've added our test user here. And now what we can do is we can SSH as that user into our system. So we're going to use our key that we just created and SSH to that machine. And you can see that I'm now prompted to touch my YubiKey, which I've just done, and we've logged straight in. And you can see that I'm able to ID myself. We can see I'm a member of the Unix allowed login group. We can see that we now have a home directory. And of course, as you'd expect, we can create things in our home directory like this. But what is a really cool feature of Kanidm and something that almost no other identity management service provides is that users can rename themselves. And so our test user can change their name. So we're going to update our test user's name to Ellie here. And normally when you hear, oh, someone can change their name, you think, oh gosh, everything is going to break because that person can now change their name. And all the home directories will break and everything is going to go wrong. Well, I'm going to log straight back into that system and I'm going to touch my key again. And you can see I've logged in. I'm still the same user with the same GID number. And not only that, I have my home directory updated and the file I just created a moment ago here as well. And so we allow like renaming users by default. There are some rules. If you really need to, you can turn that off. But we really want to respect people and their ability to change their name for any reason. Like if someone gets married or leaves a partner, you know, people change their names all the time. We need to support this as an identity management service, and so we made this a first class component of Kanidm. So at this point, we've now got our OAuth working. We've got the ability to log into systems. We have SSH key auth. We've got passkeys. And you might be thinking, wow, this looks awesome. And I really wish I could migrate from something that I already am using. So it turns out we can do this. We have the ability to migrate from other systems, and for the purposes of this demonstration, I've set up a free IPA system here, and as you can see, there are 10,000 users on this system. A good friend of mine, Fraser here, works here in Brisbane on free IPA and was at the conference that I recently visited, and so I've honorarily added them into this instance as they were a great inspiration for this project. So we're going to log out here of the administrative user, and we're just going to quickly log in as Fraser. And sorry, hang on, I have to get the TOTP manually because free IPA, it's all on one. Where is it? Sorry about that. Fraser. Okay, so I now have to type the OTP in. It doesn't autocomplete 189. Okay. And now I've logged in. So Fraser's account is here. You can see what their login shell is. They have a SSH public key, and as you just saw from that login, it required a second factor or a TOTP here in order to actually complete the login. So what we're going to do is we want to synchronize all of this into Kanidm so that you can run both services in parallel for an extended period of time, and that's what we support. So you don't have to just, you know, do a big bang migration. You can run the two in parallel and synchronize that data over time. And then at the end, once you've moved everything off, then you can move over to Kani, or you can even run them in parallel indefinitely if that's what you want. So what we're going to do is we're going to come back over to our Kanidm server, and we are going to create a synchronization agreement. So we're going to create that for the IPA sync, an agreement called IPA sync here, where we consume data from free IPA. We want our instance to know that if a user of free IPA logs in and wants to update their credentials, they need to go back to the free IPA portal in order to actually perform that update. So we're going to inform the credential portal of that information. And now we need to actually generate a token for the synchronization tool to work with. So there's a synchronization tool which sits in between Kani and free IPA and actually does the work of pulling data from free IPA, converting it into a format that Kani can understand, and then sending it to Kani where it's then accepted and validated. So we're going to use this token, and we are going to update our sync agreement here. So I've set this up earlier. So we've now set the token here, and you can see that again, we have that cron scheduler of how often to synchronize, and we've pre-configured the details of the IPA instance. There is a little bit of pre-configuration on the IPA instance you need to perform, and that is documented in our book as well. So now that we've done that, we can actually create and run our synchronization agreement. So here we're going to create a new container with an isolated user, and we need to bind in Etsy hosts just for the purpose of this demo environment, our Kani config and the Kani CA certs, the IPA CA, the IPA synchronization config file, and we're now going to actually run the IPA sync tool using that configuration file. So we can run it with the -n, which is a dry run, and the dry run will now complete and says, yep, all the data that I saw from free IPA, I believe that I can successfully send this to Kanidm. So remember, this is 10,000 users and 5,000 nested groups that I'm about to send over to Kanidm. So I'm going to rerun that command without the -n, and this shouldn't take too long. Now, for the reference, at the start of the demonstration, I discussed that we needed to add a OpenSSL legacy config. This is why. We need it for free IPA, as its password hashes are stored in a older format, which OpenSSL doesn't support anymore by default. And so as a result, we need to add that legacy config to enable some older, weaker crypto in order to actually bring in the passwords from FreeRPA. So we can see here that the actual migration took about, 12 seconds? So 12 seconds to import 15,000 users with nested groups. That's pretty good. I'm pretty happy about that. And we can immediately go and search for Fraser here. And you'll see we've brought them in. They are a synchronized account. They have the same GID number ending in 505 here as from FreeRPA. We even have their SSH public key, and we can see what we even brought in their groups such as Unix users and their preferred login shell. So we've fully synchronized all of the users and groups here from FreeRPA now. And so what we can actually do is we should be able to now just log straight into the web UI. So if I sign out of our test user here and I log in as Fraser, you'll see that the 2FA auto completes, as does the password, which is exactly what we want. And so we get this really nice, seamless, easy sign in, even with just 2FA or TOTP and a password. So it makes it really easy to log into, unlike a lot of other applications where you need to type the TOTP in and all of that kerfuffling. So we can log in. And of course, if we are added Fraser to the Nextcloud Access group, they would be able to log into it from here. And if you have a look at the credentials portal, we now need to fill these values again in order to re-authenticate. And you'll see here that this account is externally managed. Some features are not available. So we go to our external portal, and here we are. We're taken straight to the page where Fraser can update his credentials, and then they synchronize back over to Kanidm at a later point in time. Something that we can do at this point is we can actually tell Kani that certain attributes will never come from the external provider. So what we can do here is we can yield the passkey attribute from the IPA sync agreement, which says that FreeRPA will never send us a passkey. So Kani has complete control of it. Normally, when you synchronize something to Kani, we say, okay, we can't change this. It's from the external provider. This is a way of saying, no, this one attribute, Kani now controls and can put it onto that account. So we're going to set this yield attribute. We're going to come back over to Fraser's account, and immediately we can now update and add passkeys to Fraser's account. So we can add a passkey, and here I'm going to use my security key again. And so we can now do that and save that. And now if we log out and log back in as Fraser, you can see we're given the choice between passkey and TOTP, and then immediately we're prompted to actually use Fraser's passkey that we just freshly enrolled. So this is a really nice way of, Kanidm being able to upgrade the security of accounts, having those passkeys there, and then when the synchronization agreement is finalized, users have already got their passkeys in place, and they can begin to remove things like those password and TOTPs. Of course, since we have synchronized Fraser from the FreeRPA instance, we can use them to log in to our client machine. So what we're going to do is we're going to add the Unix users group from FreeRPA. So we're going to say, okay, well, this way, the Unix allowed login group also inherits members from the FreeRPA group, Unix users. And the reason for this is that this allows, oops, what have I done wrong? Operation ID, check all names. I don't know what I just did wrong there. Let's have a look. Unix allowed login. Let me try this. I think I'm typoing something here. I shouldn't. And the group. Oh, I've lost. There we go. Okay, it was a typo on my part. So we can add the Unix users group here. And what this means is that since Kanidm has recursive group support, users that are managed from the Unix user group on FreeRPA, they can be managed in FreeRPA and then synchronized across to Kani, where they'll automatically now inherit the Unix allowed login group permission, and then that can be used. And if we have a look now again at our Phrases account, we can see here that this has already taken place where they've now inherited that Unix allowed login because of that recursive group membership. So because of that, we can now log in as Fraser to our client machine, and we're straight in. And again, we have that home directory created, and we're able to actually, confirm that the UID numbers match everything ending in 505, which if we come back over here, again, ending in 505. So we have logged in as Fraser. And so, yeah, there's a really nice, easy way here in order to actually migrate over from an existing identity service to Kanidm when you want. And as mentioned, I said that the backups will be running every minute in the background, and here they are. So we've now kept the last 7 backups every minute in the background, and so you can see that this makes it really easy to actually do backups of a service because they're running in the background. They can be snapshotted and then they can be exported and used in other services. So that concludes the demo, and I hope that you have enjoyed this. Now, I will say, Kanidm is not a perfect piece of software. We do have our weaknesses, and one of those that you probably have seen is that the web user interface does need a lot of work. Some really great community members are already working on this, and there's actually a few things in 1.5 that are coming out soon which already really build on this, and I think there's only more is going to happen here, and it's going to continue to improve. We don't have graphical administration of users and groups. Again, this is tying into that web UI stuff. That is already beginning to change. We're starting to see some really excellent community contributions in this space. And so I would expect that, within the next few releases, we'll start to see the foundations of that build up and really start to grow. So it's going to be a lot easier for people to administer accounts and groups using the web user interface. Currently, we don't support internationalization. This is something that we needed to lay a lot of foundations for, and we've started to put those in. And it is something that we do want to support, but it is going to take us time in order to achieve that. We don't support SAML, and it's depending on how things go, it's possible we may never. SAML is a remote authentication exploit that happens to sometimes actually let legitimate users log into services. And so it's very difficult to want to actually include SAML in Kani as a result because of those security risks. And just because of SAML's complexity in how that it works from a cryptographic standpoint, it's not a very nice thing to actually want to implement. It's a lot better to be pursuing things like OpenID Connect and OAuth 2, and especially the upcoming OAuth 2.1. And of course, like any project, we have growing pains. Our community has grown, our user base has grown, and we are experiencing the same growing pains that so many open source projects experience as they expand. But I really do hope today that we have shown you the strengths of Kanidm, that I've shown you some of the strengths of Kanidm. It is an all-in-one system. You don't need extra parts. It's really easy to diagnose errors, and it's really lightweight. So everything I showed you today was run in a virtual machine with 1 CPU and 2 gig of RAM. And, running a 10,000 user and 5,000 groups in that scale of machine, not many systems could actually achieve this. I can't think of many others. And so, Kani is really easy to set up and deploy, even on a Raspberry Pi. It's very well documented. We really try to take documentation very seriously for our features. We're the only PAM and NSS service on a Unix system that actually supports hardware cryptographic binding of secrets in terms of the TPM, and we only want to expand this. We want to expand our integration with TPMs and what we're able to do with them and how we can actually manage secrets in really interesting and user-friendly ways and really secure ways that respect people's privacy. We're the leader in WebAuthn, especially in the open source space. We were the first open source IDM to support passkeys. We're the only one that supports attestation, and we continue to be on the edge of that. I'm very proud of our community and what they've done with our WebAuthn and our passkey integration. We love contributions. We've tried to make the project as easy as possible to contribute to. We've had so many new contributors in the last few months, and I think that really shows. And I think most importantly, we have the most lovely community of people. The Kanidm community has been such a positive and cozy environment, and very motivational, very kind and caring group of people who really want the best for not just Kani as a project, but also the users who have to interact with Kani. And I think that really shows in what we've created and how we approach the project. And ultimately, I think that's such a lovely reflection, because when I created the Kani project, what I wanted to set out to create was a system that was accessible, respectful, secure, and friendly. And I really hope that this demonstration has shown this, and I hope that as you, if you look into Kani further, that this really comes through, because we really want identity management to be something that everyone can have and interact with and use in a way that is secure and respectful of them. So for more information, again, our GitHub has all of the information that you need in order to get started. Our community chats, the book is all linked from there, as well as the developer guides and more. And if you have any questions, we are always more than happy to help out. And I would like to thank you for taking some time to watch this presentation. And I really want to thank everyone in the community who has contributed so much to this project, raising issues, writing documentation, giving good feedback. It has been such a wonderful thing to see, and it's so very appreciated, and it's made Kanidm what it is today. So thank you very much, and I hope you have a great day.